students, in the last class we are solving problems on continuity and discontinuity. Especially we have solved problems on discontinuity of a function. So today we are going to solve few more problems. So it is given f of x is equal to x plus 2 if x is less than 1, 0 if x is equal to 1, x minus 2 if x is greater than 1. This is the problem given. We need to find all the points of discontinuity. We need to find out the points of discontinuity here. So how to solve them? Let us write. When x is greater than 1, f of x is x minus 2. So x minus 2 is polynomial, f is continuous. When x is less than 1, f of x is x plus 2. You know it is polynomial. I conclude f is continuous. We need to test that x is equal to 1. Let us take that x is equal to 1. I take left hand limit as x tends to 1 minus f of x is equal to limit as x tends to 1 minus, which is 1 minus less than 1. Less than 1 is x plus 2. If you substitute the limits, you get 1 plus 2 is equal to 3. I write limit as x tends to 1 plus f of x. Limit as x tends to 1 plus f of x. 1 plus means greater than 1. Which is the function defined for greater than 1? Which is x minus 2. So I get here 1 minus 2, which is minus 1. Can verify here. Limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. That is, left hand limit is not equal to right hand limit. When left hand limit is not equal to right hand, see here left hand limit is 3, right hand limit is minus 1. They are not equal. I conclude f is not continuous at x is equal to 1. So, for all values of x greater than 1 it is continuous, for less than 1 it is continuous, for x is equal to 1 it is discontinuous. We conclude that the point of discontinuity is x is equal to 1. I move on to the next question. It's very simple. Discuss the continuity of the function f of x is equal to, I have given f of x is equal to here x plus 2 if x is less than 0, x minus x plus 2 if x is greater than 0. That's what the question is. So we need to check whether it is continuous function or not. So discuss the continuity. It's very simple. So it is less than 0 and greater than 0 it is given. So let us consider f is continuous or not. See, for x less than 0, please try to solve this. See here, I take it as greater than or equal to. When x is greater than 0, what is f of x? Minus x plus 2. It's a linear polynomial. I conclude f is continuous. I think you have understood. When x is less than 0, f of x is x plus 2. It's a polynomial. F is continuous. So for all x greater than 0 and less than 0, it is continuous. Let us take at x is equal to 0. What happens? Limit as x tends to 0 minus f of x is equal to limit as x tends to 0 minus. 0 minus means less than 0. For less than 0 it is defined as x plus 2. When you apply the limit 0 plus 2 which is equal to 2. Limit as x tends to 0 plus f of x. 0 plus means greater than 0. 0 plus greater than 0. For greater than 0 it is given as minus x plus 2. Look at the function. Minus 0 plus 2 it is 2. So what is your conclusion? Left hand limit is equal to right hand limit. Let us take f of x is equal to minus x plus 2 for x is equal to 0. F of 0 will be minus 0 plus 2 which is equal to 2. So I conclude limit as x tends to 0 minus f of x is equal to limit as x tends to 0 plus f of x is equal to f of 0. So what is your conclusion? F is continuous at x is equal to 0. For all x less than 0 it is continuous. For all x greater than 0 it is continuous. At x is equal to 0 it is continuous. Hence we conclude that there is no point of discontinuity. I think you have understood this. Same type of problems. You should know the skill of solving each problem. Very simple. I take up the next one. F of x is equal to, discuss the continuity it is given. F of x is equal to x, if x is greater than or equal to 0, x square if x is less than 0. This is what given is. X and x squared it is given. So we need to test whether it is continuous or not. Very simple. When x is greater than 0, f of x is x. Now x is a linear polynomial, hence f is continuous. So when x is less than 0, what is f of x is? It is x squared. X squared is a quadratic polynomial. No? So f is continuous. We have solved individually. X squared and x we have proved that they are continuous functions. Now f is continuous. Further, we need to test at x is equal to 0. Very simple. Limit as x tends to 0 minus f of x. 0 minus means left hand limit. Identify the function which is defined for less than 0. For less than 0 it is x squared. 0 squared is 0. Left hand limit is 0. Let us write limit as x tends to 0 plus f of x. 0 plus. Limit as x tends to 0 plus. 0 plus means greater than 0. For greater than 0 it is x. It is 0. So left hand limit is equal to right hand limit. Then at x is equal to 0. Identify at x is equal to 0. F of x is x. F of 0 is equal to 0. Now limit as x tends to 0 minus f of x is equal to limit as x tends to 0 plus f of x is equal to f of 0. So what is your conclusion? F is continuous at x is equal to 0. For all values x less than 0 it is continuous, x greater than 0 it is continuous, even at x is equal to 0 it is continuous. What is your conclusion? There is no point of discontinuity. That is the conclusion. Now we have already solved many problems of this type. How to find the discontinuity of the given function. Now we move on to the next problem. It is about the algebra of continuity of the functions. So algebra of the continuity functions, you know, it is better you remember this, very very important. If f and g are the two continuous functions, remember, suppose if f and g, this is algebra, we need to have a note of this, algebra of continuous functions. Algebra of continuous functions. Please have a note of this. So, if f and g are continuous functions, remember, if f and g are continuous functions, then f plus g, f minus g, f into g, f divided by g are continuous functions. You can easily prove it. Suppose if we have two continuous functions, sum of two continuous functions is continuous, difference of two continuous functions is continuous, product of two continuous functions is continuous, and quotient of two continuous functions is continuous, provided this g of x is not equal to 0. This is the basic property you should know. If f and g are two continuous functions, then their sum, difference, product and quotient of the continuous functions are said to be continuous. This is about the algebra of continuous functions, which you need to remember. This is very, very important concept, algebra of continuous functions. Okay, so then we have already proved about the rational function. Then ask me a question like this. Prove that a rational function is continuous. Prove that a rational function is continuous. I have to prove that a rational function is continuous. See how a rational function will be. F of x is equal to, suppose we may have like p of x divided by q of x. This is the rational function where q of x is not equal to 0. Now you know this. I've already solved a problem of this type in the last class. So a rational function is a function of the form p of x divided by q of x. Now let us take the continuity at a point x is equal to a. You take up limit as x tends to a, f of x, limit as x tends to a, p of x divided by q of x. What is that? P of a divided by q of a. Now, f of x is equal to p of x divided by q of x. What is f of a now? It is p of a divided by q of a. Just I will conclude. Limit as x tends to a, f of x is equal to f of a. See, limit as x tends to a, f of x is p of a by q of a. F of a is also p of a by q of a. So I write f is continuous at x is equal to a. So what you can write it in general? You can generally state that every rational function is continuous. So already we have proved every polynomial function is continuous. We have solved these type of properties. Every constant function is continuous. Every identity function is continuous. A rational function is continuous. Polynomial function is continuous. These are the basic concepts which you need to remember. Here we have proved that every rational function is continuous. Next problem. It is given. Write on the problem. Discuss the continuity of the sine function. This is what the question is. Discuss the continuity of the sine function. Suppose if you have f of x is equal to sine x. Check whether it is continuous or not. You know how the sine function will be, you know the graph of this function. This is x and y, 0, 0, 90 degrees means 1, 180 means 0, 270 is minus 1, 360 is 0, minus 90 is minus 1, minus 180 is 0, like that it continues. Now how to plot this? X and y. Here we have got 90, 180, 270, 360. Here it comes minus 90, minus 180, minus 270, minus 360. Here it is plus 1, here we have minus 1. 0, 0, 90 degrees 1, 180 0, 270 minus 1, 360 0. Last year we have solved this. And similarly for 90 it is, for 0 it is 0, for minus 90, 1, minus 270 plus 1, 360 0. How the graph will be? This is the graph. For 360 it is 0. So this is the graph of sine function between 0 to minus 360 to plus 360. Minus 360 to plus 360, you can see that it is a continuous function. There is no break in the graph of the function. How to verify here? Limit as x tends to 0, x tends to a in general, f of x. Limit as x tends to a, f of x is sin x here. When you substitute, you will be getting sin a. Now, f of x is equal to sin x we take. What is f of a here? F of a is equal to sin a. So, we can conclude that limit as x tends to a f of x is equal to f of a. So, what is your conclusion? If this is graphically, that is, they have proved using definition, f of x is equal to sin x is continuous. So, from this we can verify that sin x is a continuous function. Very simple. You can write the graph using the standard values and then you can prove that it is said to be continuous. Similarly, we can verify f of x is equal to cos x is continuous or not. Right? F of x is equal to cos x. F of x is equal to cos x. You need to test the continuity of this function. F of x is equal to cos x. First, prepare the table for this. You know how to prepare the table for this? Very simple. X and y. Cos 0 it is 1. Cos 90 it is 0. Cos 180 it is minus 1. Cos 270 it is 0. Cos 360 it is 1. Minus 90 it is 0. Minus 180 it is minus 1. Minus 270 it is 0. Minus 360 it is 1. Is x and y. 90, 180, 270, 360. Minus 90, minus 180, minus 270, minus 360. It is 1, minus 1. For 0 it is 1, 90 0, 180 minus 1, 270 0, 360 1, minus 90 0, minus 180 minus 1, minus 270, 360 it is plus 1. How the graph of the function will be? Need to write the graph. This is the graph of the function. As you can see, it is continuous between minus 360 to plus 360. This is the graph. There is no break in the graph of the function, hence it is said to be continuous. Further, limit as x tends to 0, f of x is equal to x tends to a, f of x. Limit as x tends to a, f of x, it is cos x. It is cos a. F of x is equal to cos x. F of a will be cos a. Limit as x tends to a, f of x is equal to f of a. f is continuous at x is equal to 0. So using the definition we have proved, using the graph also we have proved. In both the cases, it is said to be continuous. So a graph is said to be discontinuous if there is a break in the graph of the function. In both sine and cos, you have seen that there is no break in the graph of the function. Hence, we conclude that f of x is equal to sine x and f of x is equal to cos x. So they are both continuous functions. There is no break in the graph of the function. So I think you have understood. Next, we need to discuss about the continuity of the tangent function. Let us take f of x is equal to tan x. Right? F of x is equal to tan x. See, very simple. F of x can be written as sin x divided by cos x. The function is not defined when cos x is equal to 0. For which values the cos x becomes 0? That is the basic question. Cos x becomes 0 for 90, 270 and etc. That is, we can generally say that it is 2n minus 1 by 2 into pi. See, if you put n as 1, what happens? 2 minus 1, 1. 1 by 2 into pi means pi by 2, 90. If you take n as 2, 2 into 2, 4. 4 minus 1, 3. 3 pi by 2. 3 pi by 2 is 270. So, this function is, I have proved sin x is continuous and cos x is continuous. And I have already told him the algebra of continuous functions. Quotient of two continuous functions is always continuous. Remember, quotient of two continuous functions is always continuous. So, what is the domain of this? So, this is continuous for all values except this, except 2n minus 1 into pi by 2, it is continuous. So, I write like this, tan x is not defined, tan x is not defined for 2n minus 1 into pi by 2. This is not defined for this value. Okay? For all other values it is defined. Since sin x and cos x are continuous, obviously tan x is said to be continuous. If you are going to write the table on this, this is x and y, 0, 90, 180, 270, 360, minus 90, minus 180 and so on, it continues. Tan 0, 0, tan 90 plus or minus infinity, tan 180 0, tan 270 plus or minus infinity, 360 0, tan of minus 90 plus or minus infinity, tan 180 0, for minus 270 it is said to be plus or minus infinity, for minus 360 it is said to be 0. Okay? So, I write demarcation lines like this, 90, 180, 270, 360. Minus 90, minus 180, minus 270, minus 360. So here it is plus 1, here minus 1, here we go plus infinity, here it is minus infinity. For 0 it is 0, for 90 it is plus infinity, it is like this. For minus 90 we have got minus infinity like this. For 90 again we have got minus infinity, 180 0, 270 plus infinity. For 270 we have minus infinity, for 360 0. Again, for minus 270 we have got minus infinity, minus 180 0, minus 90 plus infinity we have. Again, we can do it like this, minus 360 0 plus 0. As you can see here, it is continuous at few points. So it is not continuous at you can see 90, at 270, minus 90 and minus 270. At these points it is not continuous. Just because tan x is not defined, tan x is not defined at 90 and 270, minus 90 and minus 270. At these 4 points, tan x is not defined. So hence it is discontinuous at those at 90, 270, minus 90 and minus 270, except those points it is said to be continuous. So we can just conclude that how to arrive at the result. If f of x is equal to tan x, we can just say that f of x is equal to sin x by cos x. Tan x is not defined for 2n minus 1 into pi by 2. Why? So when 2n minus 1 into pi by 2, if you put n is equal to 1, it is pi by 2, 90 degrees. If you put n as 2, it is 3 pi by 2, 270 degrees. At those points, it is not defined. So we know that sin x is continuous and cos x is continuous. Quotient of two continuous functions is continuous. So we can just say that f of x is equal to tan x. Tan x is sin x by cos x. We know that sin x is continuous, cos x is continuous, and quotient of two continuous functions is always continuous. Hence, we conclude that f of x is equal to tan x is continuous except for 2n minus 1 into pi by 2. I think you have understood this particular problem, and graphically also I have written how to solve this problem. So we move on to the next one. F of x is equal to cot x. F of x is equal to cot x. You have to solve this problem. F of x is equal to cot x. Cot x can be written as cos x divided by sin x. Cos x divided by sin x. See here, cos x is a continuous function, we have proved that. Sin x is a continuous function, we have proved that. Using algebra of continuity functions, we know that quotient of two continuous functions is continuous. But we can say that cot x is not defined. Cot x is not defined for x is equal to n pi, where n belongs to z. What is that n pi? You know, sin x, when sin x becomes 0, when x is equal to 0 degrees, x is equal to 180 degrees, 360 degrees, so on. When you put n as 0, we get x as 0. When you put n as 1, we get pi. When you put n as 2, we get 2 pi, which is 360, so on. So sin x becomes 0 for 0, 180, 360 and so on. So cot x is not defined for x is equal to n pi. So what is your conclusion? How we can write this? You can write the graph similarly by writing the table, and it's similar to tan x graph. So how to arrive at the desired result? F of x is equal to cot x. Suppose if they ask you to verify the continuity of cotangent function cot x, first you have to write f of x is equal to cos x by sin x. We know that cos x is continuous and sin x is continuous, and quotient of two continuous functions is continuous. So we just conclude that this cot x is not defined when the denominator sin x becomes 0. So it becomes 0 for x is equal to n pi. So we just define cot x is not defined for x is equal to n pi. So just conclude cos x is continuous, sin x is continuous, quotient of two function is continuous. Hence f of x is equal to cot x is continuous except for x is equal to n pi. I think you have understood. Similarly, f of x is equal to cosec x. You need to test the continuity of cosec x. So cosec x can be written as 1 by sin x. 1 by sin x, right? You know, 1 is a constant function. So constant function numerator is continuous. Denominator is sin x. You know, sin x is continuous. We have proved using graphically and using definition. Sin x is functional. And you know by algebra of continuous functions that quotient of two continuous functions is continuous. But remember, cosec x is not defined for x is equal to n pi. See, when denominator becomes 0, 1 by 0 is not defined. So, for x is equal to n pi, sin x becomes 0 for x is equal to 0, x is equal to 180, x is equal to 360 and so on. So, we conclude that cosecant x is continuous except for x is equal to n pi. That means f of x is equal to 1 by sin x. 1 is a constant function which is continuous. Sin x is a continuous function, but quotient of two continuous function is continuous. So cosec x is not defined for x is equal to n pi. Hence we can conclude that cosecant x is continuous for all values except x is equal to n pi. You can write the graph also for this. Next, f of x is equal to secant x. How to write f of x is equal to secant x? Secant x can be written as 1 by cos x. Understood? 1 by cos x. You know, numerator is 1. 1 is a constant function which is said to be continuous. Denominator is cos x. We have proved it is continuous. And we know that by algebra of continuous function, quotient of two continuous functions is continuous. So, f of x is equal to secant x is continuous. But when cos x becomes 0, we write secant x is not defined. Secant x is not defined for x is equal to 2n minus 1 into pi by 2. That is, when cos x becomes 0, cos x becomes 0 when x is 90, 270, 540 and so on. Put n is equal to 1 here, pi by 2, 90. Put n is equal to 2, 2 2s are 4, 4 minus 1, 3, 3 pi by 2, that is 270. So, f of x is equal to secant x. How to conclude? How to arrive at the answer? F of x is equal to secant x. It is f of x is equal to 1 by cos x. 1 is a constant function which is continuous. Cos x is a trigonometric function. You know, we have proved it is continuous. Quotient of two continuous functions is continuous. Conclude that f of x is equal to secant x is continuous for all values except x is equal to 2n minus 1 into pi by 2. I think you have understood how to write the answer. Today in this class we have solved all the continuity. We have discussed with the continuity of all 6 trigonometric functions. We have discussed the continuity of sine function, cos function. Sin x and cos x are continuous throughout, but tan x and secant x, remember they are continuous except that x is equal to 2n minus 1 into pi by 2. Similarly, cot x and cosecant x, they are continuous except that x is equal to n pi. So I think you have understood all these problems. I have written graphs also for this. So in these 4 classes we have solved many problems on continuity. You know the basic definition of when the function is said to be continuous, when it is said to be discontinuous. I think I have understood all these problems. That's all for the day. Thank you.